So, good afternoon, everybody. Welcome to Diversity Hackathon. We're thrilled to have you here today. And this event is a fantastic platform for you guys to show your skills, learn new concepts, as well as engage with exciting world new of data analysis and predictive modeling. So in this hackathon, our primary focus will be on linear regression, a cornerstone of statistical modeling and fundamental tool in the data science toolkit. So part 1 and 2 of the challenge will test your understanding and applications of linear regression, which allows you to demonstrate your grasp of the essential technique. Part 3 will push your boundaries by introducing to another type of regression and making sure your knowledge is even more extensive. So for those who might not be able to new to this topic, there's no need to worry. So we'll be providing you with a document which you guys can look at, and it's like everything is a learning process for everyone. So our goal is to help you not only to understand the concept as well as to make them effectively understandable. And understanding the theory behind the linear regression is crucial for you guys to be able to participate in this hackathons first. So we'll be explaining that first. And so why focus on linear regression, right? So what is the core? Why do we do this? So because it's one of the simplest but most powerful tool for predictive modeling, so which allows us to understand the relationship between variables and make informed predictions. And by mastering linear regression, you will not only be able to build a stronger foundation for further studies in data science, but also you'll be able to apply this in machine learning as well. So throughout this hackathon, we will emphasize the theoretical foundations of linear regression. We believe that a solid understanding of the principles is very essential for you guys to proceed on. So once you're comfortable with the theory, we'll be going forward to the practicals. So you learn how to use linear regression to make exciting predictions, analyzing data trends, and solve real-world problems for these challenges. And when we designed the hackathon, we made it both fun and educational for everyone. So our aim is to walk you away from this hackathon from a deeper understanding of linear regression, as well as an improved problem solving skills and a sense of accomplishment that you guys achieved something. Right. So whether you're a beginner or experienced data enthusiast, there's something for everyone in this challenge. So there's no need to worry. So yeah.
Regression. So kind of like Monish said, a lot about artificial intelligence is modeling how our mind thinks, and there are many ways to do so. So for example, in our brains, neurons connect and fire signals, which inspire the ideas for neural networks. And in our case, we want to model how our brain might predict outcomes based on data. So this is where regression comes in, linear and nonlinear, like Monish said. So in simple terms, regression helps to see the relationship between two things and make predictions based on that relationship. It's basically like drawing a best fit line on the scatter plot to see the trend and use that trend to make informed guesses about new data.
All right, so now here's an example of how to use the theory behind linear regression. So right here we have sample data. Sorry, my bad. So here we can imagine that you're a farmer, and over some time you've kind of taken notes on how the amount of rainfall affects the amount of crops. So we can see that the inches of rainfall directly corresponds to the value of how many crops you can get, right? So kind of the theory behind linear regression is first you would turn this bit of data into data points and you'd graph them. And then a linear regression model would use the relationship shown here and draw a line of best fit. And then using the line of best fit, you can make predictions on new values. So say you want to find how many tons of crops you'd get with 40 inches of rainfall. The linear regression model would use the line of best fit to go to the 40 point on the X value, and it would give you the Y value. So now Monish is going to talk about the rules.
Yep. For the rules, yep. So for the rules, so make sure you guys have a Google Colab or some coding software which runs Python, which is also installed on your device. And make sure you guys have a working camera and microphone so that we know like you're on the Zoom. And make sure to remain muted when actually the coding event starts so that everybody's comfortable using it. And also no using of ChatGPT or Gemini or any AI tool which could assist in solving the questions. And please submit all your work by 2 p.m. So those are all the rules. Yeah.
Yep, so like for now you guys are good, but like around maybe like 12:30ish Eastern time, if you guys just keep on your camera when we start the event, that'd be great. Thank you.
All right, so now we're gonna go over the different challenges. So real quick before I start, the challenges are gonna like progress in difficulty. So challenge 1 is gonna be the easiest, and challenge 3 is gonna be the hardest. So for challenge 1, we have data right here, and for question 1, all you gotta do is you have to draw a graph of what a regression model would look like for this data, and you can do this either virtually or on paper, and then you just have to take a picture and submit it right here. And then for question 2, you're gonna have to find the slope of the line of best fit and also the intercepts, and then either explain or show work for how you found both of them. For the slope, you're probably gonna have to like show your work, and then intercepts, just explain how you got it. And then question 3, just explain what makes a good line of best fit, and then also give us an example of what you think a bad line of best fit is. And then for question 4, talk about what you think the downsides of using linear regression models are, and then try to provide an example.
All right, guys. So for challenge 2, this will involve some coding. So like at the top right here, we have a link that like helps explain some of like the necessary libraries in case you're not familiar with them. And in this black box right here, here's the starting information we've provided you guys. So we've given you your from and your import statements. And in the data set, we're testing how hours studied corresponds to a higher or lower test score. And your hour studies are between 1 through 5, and your test scores are between 52.5 to 82.5. So our first question, challenge 2, you were given the import statements in the data. Just please define and create variables for your test scores and hours studied. The next question, initialize your linear regression model. So not taking in the data, but like just the actual linear regression model itself. The next one, so now we're gonna train the model to like predict the scores and create like a line of best fit. So this part of line should ideally take this part of the challenge should take 4 lines of code, and we've given you lines 2 and 3. So for the first line of the code, you should take in a user's number of hours studied and return an integer. And when you do this, make sure you ask them a question about the number of hours studied and take it in. Lines 2 and 3 are given to you, so that should help you out with like seeing where this is going. And then for line 4, just print a statement that like displays the number of hours the user studied. And then in the same print statement, it should also show the predicted score based on the inputted number of hours. And then for challenge 8, now we want you to actually graph and display the regression model to the terminal. So this part of the challenge should contain 7 lines of code, and we have provided the starting function for each line of code. So for example, your first line of code should start with plt.scatter, and you have to input something. Second line should start off with plt.plot, and that should input something. And each of the 7 lines should be different, and that should, like I said, return a graph or like a regression model to your terminal. And then the last part, so we have a couple of bonus questions throughout the hackathon. These are completely optional. If you're in high school or you have like prior coding experience, we do recommend that you try these, but they will not like hurt or harm you. They're just like adding on to the challenge and giving you a little bit more of a look into regression. So for our bonus question for this one, we've given you like a data set with a set of values, and we want you to interpret this data set by calculating the mean, median, and mode. And then if you can also just like graph or draw a simple histogram to illustrate these values, and then just explain a little bit about what you noticed for them, that's what we're looking for in this question. Monish will go through the third part of the challenge.
So for the third part, right? So this is like the ice cream sales, and you're going to be given a data set to this the whole ice cream data set, and you will be able to analyze this and make the predictions for the ice cream sales, and also make sure to include like the statement to convert from all the data into degrees to Fahrenheit. Which, yes, so that's all. Yeah. and you'll be doing the same thing as 1 and 2. And there's a bonus. So if you can do this, it's great, which you can earn more points, which can help you win this hackathon. So the bonus for this is try a linear regression model on the above dataset. So if you'll be able to if you guys already know how to code a bit, this will be very easy for you guys with a bit of research. So yes, yeah.
Yeah, I'm gonna just go over this one a little bit more for challenge 3. If you guys either also have a little bit of materials, but this is a non-linear regression model. For challenge 3 for ice cream sales, it's actually polynomial regression. So if you're not familiar with that, we have an article there that can help explain like how polynomial regression work, what makes it different. Like it outlines like some of the different aspects of codes that may not be as familiar. Challenge 10, you just really just want to write the entire code for the polynomial regression. And for challenge 11, once your code is working, hopefully it will work, just attach like a screenshot showing what your model would predict for like the given values in Celsius.